let's talk about the bell work. It says evaluate, and they've given me a value for x right here. So I'm going to take this -2, and I'm going to put it in anywhere I see an x in this equation. And we're going to see what that gives us back for y. So I have 2, and then I'm going to substitute in this -2 squared -3, and then I substitute in another -2, and then +5. You guys okay with that so far? So anywhere I saw an x, we've now replaced it with -2. So now I'm going to use order of operations to finish evaluating this. Order of operations starts with P, and that stands for what? Parentheses. I have parentheses here, but I can't do anything in it. Yeah, it's already fully simplified. It's just a number. So what comes after the P?
Exponents.
Exponents, E. Do we have any exponents? This exponent, we've got a little a little 2. What does that mean to do?
Square.
Square it. What does squaring mean?
Multiplying by itself.
Multiply by itself. So -2 times another -2, +4. So this is +4 times that 2 in the front, -3, and then we have our -2 here still, and then +5. So far, so good? All right, so we've done our parentheses because we didn't have any. We did our exponents. That's how we got the +4. Multiplication. How many places do you see multiplication happening? 2. Once right here. That would give me 8. And then it's happening again right here.
So +6.
+6. So +6 and then +5. So 19. 8 plus 6 gives me 14 +5. So this fully evaluates to 19.
Or 6 plus 5 is 11.
Yep, you can absolutely do that too. All right, second one down, it said find the sum of the solutions. So the first thing I need to do is find the solutions. And then the second thing I will do is find the sum of those. What kind of equation are we looking at here? Yep, this is quadratic,
Oh, yeah, vertex form.
not in vertex form,
That's not vertex.
factored form, yes. We're going to factor this. So what do I look for first when I'm factoring something?
GCF.
GCF.
There's no GCF.
How do you know there's no GCF?
Because
There we go. 5 is an odd number. 36 is an even number. They don't have any factors in common because the only things that go into 5 are 1 and 5. So no GCF. Also, anytime our A value is 1, we're not going to have a GCF. So then I'm going to make my X, and I'm going to see if I'm allowed to use the shortcut. Can I use the shortcut here?
yes,
How do we know?
because X is 1.
Yep, our A value is 1.
-36 and then -5.
Yep. All right, so right here, A equals 1. I can use the shortcut. And that makes me happy. So I'm going to do my X. We multiply the A and the C, 1 and -36 up on top. So 2 numbers that multiply together to give me -36, but add to give me -5. 9 and 4. I want it to add to be a negative, right? -9. If the bottom number, the B value, is negative, the bigger number is negative. If the bottom value, the B number, is positive, the bigger number is positive. All right, so how do I use those two?
You put them
Do I need them in a box?
actually shortcut.
I can use my shortcut. So what are my factors then?
-9 and 4. X equals -9.
Not x equals negative. There we go. X minus 9 and x plus 4. Those are my factors, which is what the x will tell me.
But you have to do the
Yes, we need to get our x's alone. So I do x minus 9 equals 0.
So equals -4.
Yes. So we have x is a positive 9 because we have to add 9 to both sides. And we get that x equals -4 because we have to subtract 4 from both sides. So these are my solutions. What did it tell me to do with the solutions?
Find the sum.
Find the sum. So what are we doing with 9 and -4? Adding them. 9 plus -4. Adding a negative number is the same as what? Subtracting. Adding a negative number is the same thing as subtracting. So this is really 9 minus 4.
So 5.
5 is correct. Give myself some more room here. There we go. So 9 minus 4, and we get 5. Fantastic. All right. I would like you guys to flip in your books to page 149. Page 149. We're going to look at question number 2. So not the top one on the page, but the second one down. I just want to remind ourselves of what A, H, and K do, because A, H, and K are going to show up with any and every kind of function we talk about, not just with quadratics.
Well, K is the y-intercept.
Not always. A, H, and K are describing movements to us. Here's where we found A in the quadratic formula, or in a transformation form, sorry. When we see a number out there, what will that value in that spot do to my graph?
Reflect compressor stress.
Yes. It will reflect it over the x-axis if it's negative.
Stuff like that too?
What'd you say?
Compress or like stretch?
Yep. Reflect over the x-axis if it's negative. Oh, we're doing A first, number 2 on that page. It will vertically stretch it or compress it. All right. What about the H value, this guy right here?
Your x-axis.
Tells us if we're going left or right. This will shift it left or right. And finally, talk to me about the K value.
You go up or down.
Up or down. So the things that A, H, and K are responsible for, we're going to see show up over and over and over. And today, we're going to take this idea and we're going to apply it to some things that we don't have function rules for. We don't have equations for. But we can still talk about what A, H, and K are doing.
Oh, wait. This board.
Yes.
Where's the other one? I mean, we have that. You don't have that.
Mm-hmm. We'll talk about that in just a second, but yes, you're absolutely right. Flip forward to page 151, so you're just going to turn the page. This graph right here. Do you see this guy? This is the original graph. We don't have a function rule for that. That's just the function f of x. I don't have an equation for it, so it just gets a name. This is f of x. f of x has been transformed. Do you guys see the dashed one on there?
Yeah.
The dashed one is the transformation. I'm going to trace over it with red so that it stands out a little bit. We want to try to describe this transformation. Since I don't have an equation, a function rule for the blue one, I don't have an equation or a function rule for the red one. That's where that f part comes in. Right. You guys see that f right there? When you see that written as part of a rule, it means I don't have an equation for my original function. So they'll use that f in there. For the most part, for what we're doing today, we can just ignore the fact that there's an f there. It does not matter. It doesn't affect anything. It doesn't stretch or compress or do anything at all. When you compare these two, the blue one and the red one, does the blue one look the same width as the original one, or does it look wider or narrower when I compare it? Wider. So down here, I would write the transformed graph is wider than the original graph. So what kind of number would A be if this is a vertical compression wider?
Negative.
Not necessarily.
It is compressed when it's a fraction, right?
Oh, it's more than.
Yeah, if it's a fraction or a decimal. So we're looking right here. Numbers that are in between 0 and 1. But it's going to be positive because if it was negative, what would it look like?
Upside down.
Upside down. It would be reflected.
I was thinking like going go left and right on the x.
Yeah. Does it look like it's gone to the left or to the right?
Yes.
Which way does it look like it went?
Left.
Left. How far to the left do you think it went? So here's where I'm looking, because I want something that I can count between. Do you guys see the very bottom of this? I'm going to compare that to the very bottom of this.
That's 3.
Yeah, it looks like it went 1, 2, 3 to the left. So h is negative 3.
And it's down.
It does look like it shifted down 3 units.
Yes.
Yep, 1, 2, 3. There we go. So what would that make my k value?
Negative 3.
-3. So I can give you a graph with a transformed graph on there, and we can count between. Now for that a value, I couldn't ask you for what a actually is, because that's really hard to find without a rule. But for the left and the right, for the up and down, we can just count, right? I want you to flip forward quite a few pages. We're going to go to 161 next. 161. So flip forward like 10 pages.
Oh, straight to it.
I've got some tables here. And we did this once before, so hopefully this feels a little bit familiar. We're going to look to see what's happening. This first table, this is my original function right here.
Oh, it's going up by like 8.
And this one over here is my transformed function. My original function, we're calling f of x. But I don't have an equation for this. So we're going to talk about the transformation h of x, but we're going to have to keep referring to the fact that like it looks just like f, except this has happened to it. So I'm going to start off by looking at just the x's here. So I'm looking at these two columns. Well, here, this one's at -2. When I look at the same spot over here, I see a +1, right? These are my x's, so this would be along the x-axis. So if 0 is right here on the x-axis, -2 would be back here, right? +1 would be right here. If this is where my original function started,
So 3.
and that same position on the transformed graph is here, which way and how far did we go?
Right 3.
Right 3. 1, 2, 3 hops. So to the right 3. So where it says transformations, I'm going to write that. Right 3. Then I'm going to look at the y column. So now I'm looking right here. It's the same as the other one, right? Here there's a 6. Here there's a 6. 7, 7, 8, 8, 9, 9. Did it move up or down at all?
No.
No.
So we don't have to write it.
Yep, this is all the same. So no up or down shift. So the only thing this did from the parent was go to the right 3. I'm curious. Look back at the x column here. If I start at -1 and I end up at +2, is that still going to the right 3? What about from 0 to 3? From 1 to 4? Yes. So we've described all of our transformations here, the only things that are happening. So we're going to write our function rule. Do we have an original rule for our function f?
No.
Then I need to put the letter f there. Because by doing that, I'm saying, this is the function that it looks like, and then I'm going to describe how it's different. So that original function was f of x, right? But then we went to the right 3. So what I put +3?
No, minus.
Why minus?
Because of the opposite.
Because it is always the opposite, yes. This guy right here, when it's in the equation, it is the opposite. This means right 3. So far, so good? That F looks funny, I know. But we're going to use that whenever I don't have a rule for something. If I have a rule, then I don't need to put the F there. If I have an equation. You can just leave it like that. If you put +0 there, I wouldn't count it wrong. But you don't have to have a +0 if it's not going up or down at all. Let's go look at that second set of tables. Same thing, f of x over here
The x's are the same.
is my original. And over here is my transformation. And Lauren, I just heard you say that all these x's are exactly the same, right?
Yes.
So did it go left or right at all?
No.
Okay, so,
No, describe it.
yep, right here, these are the same as right here. So no left or right shift. So what is h then?
No. Yeah, 0.
0. I'm not going to need to write it down since it didn't move left or right at all. All right, let's go look at the y's now, the output. Are these the same?
No.
No. So let's compare. Let's start with the top. This one starts off at 3.
It's 10.
When I look at the same spot over here, it's at -7. I'm hearing people say 10. Let's draw it out to verify, okay? Am I going up, down, or left, right with this? Up or down, right? Because it's my y column. So I'm going to draw it like this. So if 0 is right here, 1, 2, 3 would be up here. 1, 2, 3, 4, 5, 6. Down here would be -7. I'm starting here, and I'm ending here. How many hops? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
This is going down, it's negative.
Yes. Down 10. So that's what I'm going to write on the line. Down 10. Since we're going down, you're absolutely right. K is going to be negative. Did we have an equation, a function rule for that first table?
Oh, yes.
Do I have like f of x equals and then a whole equation? No. So I just have to call it f of x. So h of x looks just like this one, except it has moved, right? It moved which way? Down 10. So I'm going to see a -10 right here. I want you guys to try that last set of tables. Try that last set of tables. Did you notice any kind of left or right shift?
Yes.
Which way?
Left 4.
Left 4. I think it's probably easiest to see if you look at this bottom point.
Or 0, -4.
Or 0, -4, absolutely. You can look at any of these because whatever affects one should be the exact same. Like if I'm looking at the second spot down, I should see the same change if I compare the third spot down or the fourth spot down. So we're going to the left 4 units. So if I'm going left 4 units, what is my H value? H is -4, but when I see it inside the equation, when it becomes the opposite, then I'm going to see what? Yes. I don't have a rule for that original transformation, right, or that original function. So I'm going to call it f of x. You're going to see a +4 in here. Yes. This is the opposite of h, and it means left 4. And then you were a little bit ahead of me, but I like it. We're going to look at the y column. What kind of changes do you notice between these? Going up 5 from 2 to 7. Up 5. So what does that mean K is?
+5.
Yep, +5. So I have a +5 right here. That means up 5. Gorgeous. Do you guys feel like you have an understanding of how that part's working?
Yeah.
Okay. Turn the page. We got 2 more problems to look at, and then we are done for today. So do you remember just a couple minutes ago before we looked at the tables and I had 2 graphs and you were able to describe it? And then we looked at the tables and we described it again and we wrote a rule. here, we're being given a rule, and we're being given a shape. So here's the original shape that we have to work with. Like this. When I look at the rule that they gave me, I can see h and k there. Can you see them? Where would I look for h? H is negative 2?
Oh, no, it's negative 3.
Why is it negative 3?
Because it's the opposite of plus 3.
Yes, so right here is where we look for h. It's always inside parentheses. So h is really negative 3, which means what? Where's it going to go? Left 3. So I'm going to write that on this line down here. We're going to do that to this graph. What about that plus 2 on the end? Who is that?
Minus 2.
Or sorry, yes, minus 2. That is k. And what does that mean we're going to do?
Go down 2.
Go down 2. So I'm going to write that down here. So far, so good?
Yes.
Now we have to figure out how to actually do that with our graph. So if I'm going to do that with the graph, technically that means every single point moves. I should see a recreation of this shape just to the left 3 and down 2. So I'm going to pick out a couple of points, and we're going to translate them. We're going to make them hop, left 3 and down 2.
What about negative 1 and 1?
Negative 1 and 1. So this point right here?
Yeah.
I like that. Let's take that point, and we're going to do what with it?
We're going to go left 3, down 2.
Left 3, so 1, 2, 3, and then down 2. 1, 2. So it's going to end up,
Right below that.
yep, right below the negative 4, right there. Are you guys okay with that?
And then 1 and 1.
All right, so hold on. We will go get that one. Give me just a second. No, we're good. Actually, yeah, let's go do that one next. 1, 1. There's another point, because that makes like a flat tabletop in the middle of my graph. What am I doing with that guy? Left 3, yep. 1, 2, 3. Down 2. 1, 2. And I translate that point. What should I do between those 2 points?
Okay.
Connect them. We're going to connect the dots here. And now I need to get the left side and the right side of this graph. Let's go do the left side first. I don't see any other big dots there, do you? But I do see where it crosses the x-axis. Where does it cross the x-axis at? Negative 2. If I can move that, then I can use my straight edge to get that line, right? Where do I want to move that point to? Yep, 1, 2, 3, and then down 1, 2. So it's going to be about here. And now can I grab my straight edge to get that line part?
Yes.
Cool, let's do that.
Wait, it's kind of seems like it's reflected. No way.
Shouldn't be a reflection.
Yeah, because
Yeah, we're just shifting. But yeah, sometimes when you shift things, it looks a little funny. All right, so I've got the middle. We got the left side. Let's go look at the right side. I need to pick some other point so I can use my straight edge to get that over there. Look at your graph, because mine up on the screen is really fuzzy.
4 and 2.
4 and 2 over here.
Yes. No, 2 and 4.
2 and 4. 2 and 4. So right here, right below the arrow. I'm going to take that point and make it go to the left 3. 1, 2, 3, and then down 2. 1, 2. So it's going to move,
Right next to the 2.
yep, right there. And then I can grab my straight edge and I can connect those. Your transformed graph should look like the original one, but like you just picked it up and moved it. We have one last graph to do this to, and then we're done for today. So let's go look at that transformation that they gave us. Here's what I'm looking at. Let's figure out AH and K. Is it going to stretch or compress at all?
No.
No.
Does it move left or right at all?
Yes.
Which way? Right 5, yes. This right here is the opposite of what I would think. And so we're going to go to the right 5 and up 20, yes. Here's K,
The graph is a bit different.
yes. So let's write this down on the line and then we'll go talk about that graph. I'm glad you noticed that. Right 5 and up 20. So looking at this graph, Lauren pointed out that they're not counting by ones, are they? Look at the y-axis. What are they counting by on the y-axis there? By 20s. So when I say go up 20, are we going to count 1, 2, 3, 4, 5, 6?
We're gonna just jump once.
We're going to count one square because that's 20 units, right? What about the x-axis? What are they counting by there? By 5s. They only have it marked every other line, right? But that means this line in between has to be 5. So 5, 10. Let's go ahead and write these in because that'll make it a little bit easier for us to talk about. All right. So I need to pick out a couple of key points to move.
What about 10 and 60?
10 and 60. So this point right here is what Lauren's talking about. And we want to make that move which way?
Right 5 up 20.
How many squares am I going to the right if it says go right 5?
1.
Why?
Because each one is.
Yeah, because they're counting by 5. So one square is going to the right 5. So right 5 and up 20 means,
8 right after.
yep, it's going to be at 15 and 80. Give me another point that we could easily move.
40 and negative 40.
You said, I'm sorry, one more time?
40 and negative 40, 40 right next to the negative
40, this one here?
Yeah.
We can do that one, and I think we should probably do this one too, the one right next to where we were. Because we want to be able to connect those two, right?
So 15 and 60.
15 and 60, let's move that one first. So right 5, it would go from 15 to 20. So we're hopping here, and then I go up 20. So it's going to be right here. So here's that tabletop, right here. Soraya pointed out like the bottom part down here. Where's that point going to go to?
45 and then up to negative 20.
45 and then up right here to negative 20. Right here. So on the original graph, that's this part. So I want to make sure to connect that to this little tabletop piece up here, right? So that I can recreate that shape. So far, so good? Does what I have in red look exactly like the original?
Yes. We need to go like this.
Yeah. I'm not totally done yet, right? Which pieces do I still need to get?
The 55 and then that's supposed to be 0.
Yep. I need to get this one, and then you're right, the one over at 0. Which one do you guys want to go get first?
55.
This one? Sounds good.
That's 55 and yes.
55 and 0. So where's that going to move to?
Over to 60 and then up to 20.
Over to 60 and then up to 20. So actually just off the graph, but barely. Looking even more like that original one. We just need to go and get the far left-hand side now, right? All right, so the original point is down here. Looks like at 0, 0.
over 5 and up to 20.
Over 5, so over to 5 and then up to the 20 here. So the original function is connected, so I'm going to connect these two. Does the one in red look just like the original one, just scooted? Perfect.
Isn't this something that we could use in real life actually? If somebody's doing like a CEO and they have to show a graphic to their boss.
Mm-hmm. Absolutely. So talking about like business graphs, those are usually graphs that we don't have rules for, we don't have equations for, and they're like, okay, we want to shift us into the future, so we want our profits to go up, that would be that vertical shift there, and we're going to move 5 years down the road, that kind of thing, yes. Over the weekend, you guys have homework 1. Homework 1 is due on Monday. This is a very short unit. You'll take the test over this unit 2 weeks from yesterday. Because in 2 weeks we go on fall break, so I'm not going to give you a test for the day right before fall break. Let's do it the day before that. And that way we can take the day before fall break to just kind of decompress. Does that sound good? Awesome. I hope you guys have a fantastic weekend.